Assalamu alaikum guys. This is Akil Ahmed. We are referring to the paper of November 15, paper 2, variant 1. And in this, we're talking about question number 3. In question number 3, the table is given. In A is a variable, in B is a variable, out Z is a variable. All three are Boolean type variables, meaning they can have true and false only. And these two would provide input signals. The third one would give output signal. And then the code is given that you are entering the data of input A, input B, and you can only enter, make sure you can only enter true and false only. Just in case if we enter, this if command tells you what? It checks all the possibilities. So it says that there's one possibility if you have false in A variable and in B is also false. That means, in other words, we can interpret this as 0. False is read as 0, false is read as 0. So that means this is the first possibility if we have zeros coming in from both the input variables. Or the second possibility is input A is false, meaning 0, and input B is true, meaning 1. And even if we have the combination of 0 and 1, then we are moving to the case number 3 now. In A is equals to true, true can be read as 1, and in B can be read as false, meaning 0, 0. So these are the three possibilities that we have talked about in this if command, that if we have 00, or we have 0 and 1, or we have 1, 0. In all three cases, the output out Z is going to be true. Only possibility to see the false output is the case that is not mentioned here. Which one is that? 1. If we have 1, then this output Z is going to be false, and in the end it would produce output Z. So either the output Z can be true or it can be false depending upon the cases. So it would jump onto then part or the else part, but the else part would run if both input will have 1. If both inputs are true, then only this else part would run. If you have a single 0 in line or you have double zeros, in that case it would produce true. And similarly, you were supposed to write down the results here. So if you have true and true would produce false, according to that if command that we just tried, would produce false. And then if you have a single 0 in line, or false or double false, in that case it would give you true. And then examiner says, can there be easier method of doing the same thing? Then examiner says, can there be easier method? So we'll write true here, and then examiner says in the next part, can we write this complicated if command using some easier method? What if we test it other way around? Meaning if we move this else part first, if we talk about this, if we consider this case first, 1, 1, so it would become a much simpler command. So we could have written this if in A is equals to 1 and in B is equals to 1, then it should display false, otherwise true. So we don't have to write such a long if command in that case. You can test the possibility of 1 and 1. So this was the requirement of part B, and I'll show you the solution also. In part B, what examiner wants it? An easier if command. So this is what I was talking about. In A is equals to true, in B is equals to true, then it has to be false, otherwise true, meaning a 0 1 or 1 0 or double 0 would produce this output true in out Z. So this was the thing needed in it. And you further said that how do we know which kind of this is matching with what kind of gate is that? So in O levels you have studied that if there are two inputs, so there are 4 possibilities. So you got the input A in A, and then in B was the other input. In A and B, these were the two input. In A, in B. Possible combinations are what? 0, 0, and then 0, 1, and then 0, and then 1, and then we say double 0, and we say double 1. Or this can be read as false, 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 true, true, false, or true, true. And then what if you are calculating out Z, outcome, the results, using NAND gate? Using NAND gate, how is that? NAND gate was opposite to AND gate. In AND gate we multiply, in that, and NAND gate we multiply and write opposite answer. So 0 into 0 is 0, but we'll write 1. 0 1 is 0, we'll write 1. And 1 0 is 0, we'll write 1. And 1 1 the 1 is 1, we'll write 0. Or we can read this as false. Or we can say true, and then true, and then true. So that if command was made to produce the results of this NAND gate. So if you go and match, you are getting the same results there. You are getting F when you have double 1. You are getting F when you have double 1, true and true. Right? So I think you should be able to understand this. Thank you.